Good morning, everybody. So today we are going to be done with triggers, and it's amazing that we could finish almost all the book. So for Wednesday, we have a few options. I can choose NoSQL. We can have a review session, or I can teach you NoSQL but don't include it in the exam. So what would you like? So review session, it will be just the same thing that we had before. So the exam, then the final exam, exam 3, will be the same, it will be similar to the second exam. So it's not going to be something very different. But do you still want a review session?
Yes.
Yeah. We can do half of the session NoSQL and then half of it review session, no? So, who says only review session? Who says half review session, half NoSQL? Okay, sorry. We lost. So,
Is this before or after the test?
what?
Is this before or after?
It's before the test. It's what, Wednesday? Only review session? Okay. So in short, I just say what is NoSQL. NoSQL is a database that is not based on tables. So you don't need to use tables anymore. And it is for big data. Usually big data in internet, for example, Google, is stored in some kind of unorganized fashion, and it is not stored in tables. And retrieving data has some tricks. So there are algorithms to retrieve data and insert data there.
What's a SQLite?
What is what?
SQLite?
SQLite?
Yeah.
I don't know. Where did you have
SQLite? Like LIC?
Light?
Yeah.
Is it part of Oracle?
I didn't see it. I didn't see it.
I don't know.
I'll get back to you.
Okay, so triggers. First of all, this is the first trigger that we had before. So I'm gonna just run it because we have talked about it before, but before that, what we are trying to do is that to make sure that every vendor state in the vendors table is actually uppercase. That's the whole thing. That's the whole point of this trigger. So triggers are actually very important. Before doing this, unfortunately in many sections they don't teach about triggers, and I insist on teaching about triggers because of this. The main point of database is enforcing rules. And you cannot enforce many rules using just traditional statements. So what kind of rules can you enforce? Have you learned to enforce so far? Primary key, uniqueness, not nullable, not null, so it is required. What other? Foreign key constraint, referential integrity, existence of foreign key. What other? Checkpoints. So the checkpoint is probably the most powerful constraint that we have learned so far, but it is only inside a table. So you cannot have a rule that is cross tables, that refers to values from another table. You cannot have a rule for that. The only rule that you have for that is referential integrity. That's the only type of rule that you have that refers to another table. Okay? So, but in practice, it is possible that you have rules, you have business rules that depend on multiple tables, or enforce a rule on one table based on information from another table. And triggers are for that. Actually, triggers are general enforcers. They can enforce all kinds of rules. You can enforce differential integrity using triggers. You can enforce uniqueness. You can enforce primary key constraints. You can enforce all checkpoint constraints, any checkpoint constraint. So trigger is essentially the generic rule enforcer. And beyond, it is not just rule enforcer. Rule enforcer is only the before kind of trigger. If you use before, just create a trigger that is before, it enforces all the rules that you want. And if you put it after, it can do even more. It can go even beyond that. And do the rules for you. Just execute the rules, something like that. So let's start with this example that we want the vendor state to be uppercase all the time. So here what we have is this. Trigger 1 executes before inserting a row into the vendors table. A trigger is defined for a table, a DML trigger. Actually, for now, just assume this. A trigger is defined for a table. So we are defining the trigger 1 for the vendors table. Okay? And the trigger runs for when we try to insert a row, insert a new vendor, or update a value, a column, this particular column, vendor state, in the vendors table, before the statement. Yeah? Except when we put for each row, it runs before each row that is being updated or inserted into the vendors table. Okay? And so far so good. Just ignore the when part for now. So what it does is simply converts the new value, the suggested value, into uppercase. So puts the uppercase of the new value into the new value. That's it. And it makes sure that it is uppercase for every row that is being inserted or updated. However, you may want to limit this execution to those the states that have lowercase just lettering in them. So because if it doesn't have a lowercase in it, it is already uppercase, you may not need to execute the block. Okay? So you can have when. So if you put when after for each row, it becomes for which rows. So essentially it becomes for each row and then for which rows, the rows that the new value is not equal to the upper case of the new value. So that means it has some lowercase letter in it. Okay? And it only executes this for those rows. And you can have a condition when you have for each row. Because if you don't have for each row, it is going to run only once for the statement. Okay? And the new and old values, so you know it is the new value that the user is trying to insert or update, and you can use old for the old value. And if you don't have for each row, of course, the new and old will not mean anything anymore, because the new and old, it will give you an error, because it's new value or old value for which row. You know, you cannot refer to the values of the rows anymore, because this becomes a table level trigger, when you don't put for each row. And the table level trigger, you don't know which row you're referring to, and you don't have new or old values. But when you put for each row, then you can have a condition, and also you can have new and old. And in the condition, you refer to the new and old just like regular variables. In the block, you refer to them as if they are bind variables. Actually, they are bind variables because their values are defined outside the script, outside the block. outside your T-SQL block. So they have to be bind variables. So that's about this, and I can run it. It creates the trigger, and here you can see the triggers. If you click on the triggers, you can see the list of triggers, and trigger 1 is one of them. You created one trigger. See? So the trigger is assigned to the table vendors. Let's try to see what happens. I'm going to update these 3 vendors. Oh, by the way, I have this statement in the trigger. Show this is from trigger 1. So we know that the trigger is running. Yeah? This is the statement that whenever the trigger runs, this statement is shown to the user. So let's run this update. So 3 rows are updated. First of all, because it is lowercase tx, the trigger runs all the 3 times. Yeah? And if you go to the vendors, if you go to the vendors table, you see that the vendor states that you put there are uppercase, tx. Yeah? So the trigger worked. And another sign that it worked is that you see this is from trigger 1, this is from trigger 1. So the message, our message ran 3 times because it ran for each row, and there were 3 rows. So it ran 3 times. Okay? But what if I do this? What will happen? I change the trigger to this without the when statement. And I make it tx. So what? So it runs for each row. Yeah. And we don't have the condition, so it runs for each row anyway. So when we don't have the condition, it is going to run for each row anyway. And when I put the condition and I try to run it, it is going to update it but not run the trigger. It did the update but did not run the trigger because the condition is not satisfied and it is already in the uppercase. Okay? So far so good. Next trigger. So here it is an interesting trigger. I want to talk about it. Here what we have is this. We have invoices. We have the invoices table. Let me show you. So there is a one-to-many relationship between invoices. We have invoices, and each invoice has items. So we have a one-to-many relationship. All right? And the value of invoice total in the invoices, so one of the columns is called invoice total. The value of this, whatever it is, should be equal to the value of all the items that belong to that particular invoice. So this invoice total should equal to the sum of the amounts for the items that belong to that invoice. Okay? That is a business rule that we have. We say that it should happen. This is our rule. This is our constraint. How can we enforce this constraint? Try to enforce this constraint. I want the items sum up to the invoice total, or the invoice total in the invoices table be equal to the sum of its items. Any idea how we can enforce this? Using checks. Where should I put the checkpoint? In the items table? In the invoices table? Here I'm referring to that data. Here I'm referring to this data. The only way to refer to the only way to enforce this rule is trigger. You need to use trigger to enforce this rule. And this is the trigger that we are using. So this is one trigger. So trigger number 2 is enforces the rule on the invoices side and says that whenever you want to add an invoice or update an invoice, whenever you want to update an invoice, just make sure that the new invoice total that you are putting there equals the sum of the values in the items, in the corresponding items. Okay? So, but it is not enough, of course. The rule should be enforced on the items table as well. We need 2 triggers. Yeah? So the first one is on the invoices. Let's talk about the one. Let's talk about the one that is on the invoices table. Here we say that before updating the invoice total, since it is enforcement of the rule, it is before, because we may want to prevent the updating. Yeah, we may want to prevent that to happen. So we say before updating the invoice total, only the invoice total. If you want to update other columns, that doesn't matter. But if you want to update the invoice total of any invoice for each row, do this. So you define this variable. So it is like procedures and functions. You can define a variable before the block. And in procedures and function, you use as or is. But here, like regular just blocks, you use declare. So in trigger, you use declare. You don't use as is. It is just a small difference, some minor difference. And I'm declaring this number, sum line item amount, that is the amount of this, which should be equal to the invoice total. How can I calculate the amount? How can I obtain the amount? I go to the to this table, to the invoice line items. I go to this table, and then I sum up the sum line item amounts using a summary query. It is an aggregate function, and I sum up the line item amounts in sum line item amount, put it there. So I obtain this value for that particular invoice. For that particular invoice that I am trying to update. And it shows the message here that we know that this trigger was actually initiated, triggered. And then it checks, is this value that we obtained is equal to the new value that we are trying to put there. So, or is the new value that we are trying to put there in the invoices equal to the value that it should be, to its correct value? If it is not, raise an error. That's it. So then it enforces this rule on the invoices side whenever you want to change the invoices table. And here you see that the sum of the item amounts is 662, and on the other hand, invoice total, the value of invoice total for invoice ID 100 is 662. We are following the rule. Let's try to break this rule. Let's try to violate this rule. So we have update invoices. We set the invoice total 600 for invoice number 100, and which should not happen, and it gives us an error. It does not let us to put an incorrect value for the invoices, for the invoice total of any invoice actually. Yeah? So, now we are enforcing the rule. Can we violate the rule? Can we violate the rule now? yes, still we can violate the rule. You can change the values of the items. You can change the values on this side. And this will not trigger any trigger. This will not trigger any procedure. You know? So we are enforcing the rule just on this side. If the user tries to change the invoices table, then the trigger runs and prevents that. Prevents violating that rule. But if the user tries to change something here, nothing runs and it can just happen. And it can be unequal. It can just violate the rule. So, how can we enforce that rule? So we are gonna put a trigger 2, on the items table. So try to do that. How can we do this? I can give you a hint. You don't need to prevent anything. One way to enforce it is to prevent it. But if you try to prevent it, it is gonna be very hard. It makes your job very hard. If one way is to just do the same thing that we did here, we do it here. I prevent adding any new item here or changing anything. So what happens is that I am preventing any change. I am preventing any change here, and now it is, for example, imagine now it is following the rule. It satisfies the condition. It adds up and matches, the values match. Imagine the values match. So I want to make a change. I want to add an item or make a change. How can I do that? If I put the trigger here, I prevent that to happen here because I'm violating the rule, of course, if I'm adding an item. So it prevents me to add any item here. If I try to change the invoice, it prevents me to do that too. So we are doomed. It is not possible because we cannot make any change from either side. So this says go change that first. This one says go change that first. Okay? So essentially what the previous trigger did, it says go change items first. Here it says, okay, it should do that. It prevents any change in the invoices. And it says, go change the items first, and then you can change the invoices. Okay? Now, if I put the trigger, a similar trigger here, if I put a similar trigger here, it's gonna say, okay, go change invoices first, and then come back here. So it doesn't make sense. I'm preventing any change from any side. Okay? Another way that I can enforce the rule is this. You can make any change, but after you make the change, it automatically updates the invoices table. I automatically update the invoices table based on the change. That's how I enforce the rule. That is a way to enforce it. So what I do is this. This time I'm going to say after. After inserting or updating, or I can actually include delete also. I can also include delete. So after any change in this table, in the items table, line items table, after any change that happens here affects the line item amount. Of course, delete and insert affect the line item amount anyway. And update can affect the line item amount if it actually affects the line item amount as one column, has this as one of its columns. And then, of course, the trigger, the rule is on the invoice line items. The rule is on this table for each row, of course, because we can update multiple rows. We can delete multiple rows at the same time with one statement. So we want the trigger to enforce the rule on every row, on every item, on every invoice. So for each row, do this. Declare this as a number, and find the new sum because someone added some item or deleted some item or updated some item. Find the new sum for that particular invoice that is being affected. Yeah, find the new sum. This is just a simple summary query. And then put the new sum into the invoices table. So update and then go from here to the invoices. So the flash is the other way around. Goes from here to here and sums up and puts the value of summation here. Puts the value here and just updates the invoices table automatically for us and says this is from trigger to be. Okay? And we run it and trigger to be is compiled. Everything goes very well. So everybody lives happily ever after. So that's good, yeah? It's gonna run. It would be great if it could run. It would be amazing. So let's see what happens if I try to insert a new item into this table, into the items table. So it should update the invoices. Yeah, it should do that. I wish. It gives an error. What is the error? Invoice line items is mutating. So what is it? Here's the problem. Now, first of all, the trigger works fine. The trigger was compiled. There is no error. Okay? There is no error in the trigger. There is no syntax error, essentially. However, there is a kind of ambiguity and confusion for Oracle. Here in the selected statement, I am trying to read values from the items table, from the invoice line items table. And at the beginning, actually the update and delete, I am checking update and delete in the invoice line items table. So I am checking values from the same table that I am actually reading the values from. So the values are changing. So I'm enforcing a rule that says whenever these values change, read the values. So it causes confusion. So when should I read the value? After each row, and particularly it is for each row. It is for each row. So there are multiple rows, and in middle of reading the rows, so I am reading the rows in middle of checking if I am changing the rows. You know, so that is called a mutating problem, the table mutating problem. So here's the lesson. When you are having for each row, you cannot use select statement. You cannot retrieve data from the same table that you put the trigger on. That the trigger is defined on. So if you define the trigger on this table and you have for each row of that table, then you cannot have select statement. It causes an error. So how can we solve it? We put this as a function and we refer to the function here. Use just a function and it's going to work here, right? No, I wish. Function does not work either because it will cause the same problem. You still are reading at the same time that you are checking the condition. You still have the same problem. So how can we solve it? How can we do this rule, enforce this rule? this trigger. Any idea? So you cannot enforce this rule on this side. You cannot enforce this using usual triggers. You have to use compound triggers. So we're going to talk about it in a bit. So keep that in mind. We need to use compound triggers for that. Now let's talk about invoices audit, the example that I gave you last week. So last week I asked you to do something, to write a trigger, to code a trigger that keeps track of any change that we make in the invoices table. So essentially audit trail. Audit trail for the invoices table. So whenever you make any change in the invoices table, you add a row, you insert a row, update a row, or do something, delete a row. There are 3 types of changes. It should keep track of that. Okay? So to start, we need a new table, invoices audit, that is supposed to store the values of the audit trail. And it has these columns. The vendor ID, invoice number, that's the invoice that we are changing, the invoice total, and action, whether we are deleting, inserting, updating, and action date or time, actually the time that we made the change to the invoices table. And this is the table that we define for the trigger. And here is the trigger 3. So, first of all, it is after, because we don't want to prevent anything. Actually, we want to insert values, we want to insert the audit trail after the change is successful. A successful change is made, after a deletion is actually made, after insertion is actually made, after an update is actually made. Yeah, after we have an update. So what we do is this. We say after insert or update or delete any change on the invoices table, after any change on the invoices table, for each row that is being changed in the invoices table, actually for each invoice, do this block. So inserting, updating, and deleting are the keywords that can be false or true based on the action that is being taken and is triggering the trigger. So inserting is true when you insert, when the trigger is triggered by the insert command. Updating is true when update command triggers a trigger. And when the user tried to delete, or deleted actually, in this case because it is after, when the user deleted, then deleting becomes true, otherwise it is false. Okay? That's the only thing that you need to know. And now, if inserted actually, because it is after, insert this row into the audit tray, into the invoices audit. So the new values and inserted, the text inserted, and the time of insertion. When updating, you put this row into the invoices audit table, into the audit tray. And the values that we are inserting there are old values. And updated word and the time of the update. And deleting, if it is deleted, we put this row and we use the old values. Of course, we use the old values. Why? Because the new values do not exist. There is no new value. So we have to use old values here because it is deleting. we have to use new values here because it is inserting, there is no old value. But here we use the old values. Why? Why do we use the old values in updating? We could use new values. Because the new values are going to be in the invoices table. We have those information. We prefer to keep track of the information that we would lose. So the old values are the values that we are writing over. Yeah? So we want to keep that information somewhere. And we are keeping this information in the invoice audit table. So let's make the trigger. The trigger is compiled. And if I insert new value, let's say I insert this. If I insert this, one row is inserted. I delete something, one row is deleted, and now we have deleted and inserted the two new rows into the table, into the audit trail. So this is the audit trail, and we have two new rows there. However, what if I try to delete this one more time? 0 rows deleted. And since it is after, since the trigger runs after deletion, so it does not insert any new row here. No, because no deletion occurred. That is because the trigger runs after deletion of each row. So it is after delete for each row. After delete for each row. And if no row is deleted, it is going to be just, it is not going to add any row to the table. So the next trigger. Trigger 4 is on the views. So remember, a trigger can be before, after, or instead of a normal trigger, not compound trigger. A normal regular trigger can be before, after, or instead of. And when you have a view, remember when we had views and we wanted to update the values of the views, there were some problems. Because a view can refer to multiple tables. Can have a join, can have something like that. And when you want to insert value or update values through the view, it can cause problems. It can cause ambiguity and problems. Yeah? So we prefer not to do that. And one way around it is using triggers. So this trigger actually says that instead of inserting into this view, do this. So if the user tries to insert a new row into this view, what happens is that it actually inserts the values, the specific values that user wants to insert into the view. It inserts those values into the invoices table, the base table for the view. Yeah? It inserts the new values into the invoices table. And that's how it's done. So if I try, for example, to do this, oops. It's not inserted, and when we see the view, the new row is inserted. This is the new row that we inserted. And actually, the row was not inserted using our insert statement. Actually, our insert statement was overridden by the trigger. the trigger actually inserted the row. So, I'm gonna talk about DDL just in a bit. For now, let's talk about it a little bit simpler cases. So, there are some commands that are obvious. So how can you drop a trigger? Drop trigger, trigger 1, the name of the trigger, drops the trigger from the database. You can also disable a trigger without dropping it. So you can disable a trigger or enable a trigger using alter trigger, name of the trigger, disable, or alter trigger, name of the trigger, enable. So it disables the trigger but keeps the trigger in your database. So you don't lose the trigger. And then you can enable it whenever you want. You can disable all triggers that belong to a table. Remember, I told you a trigger belongs to a table, to one particular table. You can disable all the triggers that belong to one particular table using a table alteration command. You alter the table and say disable all triggers that belong to this table. Or you alter the table and enable all its triggers. Okay? That is good when you don't know the name of the triggers. And you can rename a trigger, alter trigger, trigger 0, rename it to trigger 10. This is just obvious. You can rename a trigger. Okay? Now, let's talk about another way that we can use triggers. So, we use triggers on update, delete, and insert. We cannot use triggers on select commands because it doesn't make sense. Okay? Can we use triggers on DDL commands? Yes. We can use triggers on DDL commands. Create table, drop table. However, as I said before, a trigger belongs to a particular table. So, if I say run this trigger after a create table command, so what table should I put the trigger on? Should I define the trigger for? I cannot define the trigger for any particular table because I am defining the trigger for the DDL command, and I am saying that for if the user wanted to create any table, run this trigger. Yeah? So what table should I assign this trigger to? No table. We assign the trigger to the database. So we say before create or drop. It can be before create, it can be before drop, it can be before create or drop on the database. It can also be defined on a schema, part of the database. But this is easier, on database. And this defines the trigger, the DDL trigger on the database. And in this example, we are raising an error that you cannot drop or create an object in this database. In this database. Okay? However, we don't have enough access to the Oracle server, to the Oracle database to make this trigger, and we don't have privilege to do that. So because if I can do that, then I can prevent anybody from creating a table there, and I don't have that much of access, and that makes sense. So you don't have that access either. But a trigger can be on DDL commands as well as YAML commands. Okay? You can have a trigger on DDL commands. Just know this. But you cannot have a trigger on select command. So, now compound triggers. This is the important part. The compound triggers. So far, we had triggers that could run after a statement, before a statement, instead of a statement, And we could have triggers that run after each row or before each row, right? So, what if I want my trigger, I want to have some rules that depend on that. First of all, the rule is multifaceted. Like a rule, part of the rule says that before each statement, part of the rule says after, part of the rule says before each row, part says after each row. So what if I want to enforce such rules? I can define multiple triggers. That's one way to do it. But what if I need to extract some information from one part and use it in another part? So before a statement, I extract some information and then use it after each row, for example. Then multiple triggers will not work. So here we use compound triggers. So first of all, we define the trigger like before, create or replace trigger. Oops. And then instead of saying before or after, or instead of, we say for the operation, the particular operation. And in this case, I'm using update. So I'm defining the compound trigger on the update operation of these columns. So I am specifying the trigger only for these columns, these two columns, on the invoices table. So again, the compound trigger is on the invoices, on the table, which is again on the invoices table. So we have this trigger on the invoices table. After that, it becomes a little bit different. So we don't put for each row or begin or declare or anything. Here we put compound trigger. Instead of putting for each row, we put compound trigger. Yeah? And compound trigger, let's say something like declare. It can serve also as declare. Then we define the values, the variables, and probably their values. The variables that we want to use throughout the compound trigger. This is this value. And then we can have multiple blocks. In normal triggers, we had one block, begin, end. That would be just the block for the trigger. In compound triggers, we have multiple blocks. We can have multiple blocks. For each situation, we can have a block before a statement. So we say before a statement is begin, the block, end before a statement, then the block before a statement. And this runs before the statement, before, in this case, the update statement, before updating the invoices. Before each row this is another kind of block. This block runs before each update in the invoices, each row that is being updated in the invoices. So it can run 100 times for a statement. After each row is updated. And after a statement, after the updated statement is done, just once, so the four statements, the four blocks are like this. And after the end, you have another end, so the ends inside the block have qualifiers. So we have end after a statement, end after each row, but the end at the end doesn't have a qualifier. So it's a end, semicolon, and a slash. It's how we define a compound trigger. So let's define it. Trigger 7 is compiled. And now that's how we do it. So I am trying So let's see how it works. First of all, this compound trigger only shows messages. It doesn't do anything, this particular compound trigger. And shows messages in each block. So here, we are trying to update 3 invoices. 112, 113, and 114. I'm trying to update 3 invoices. So what happens if I run this statement? What do you expect to see? Anybody? What do you expect to see as a result of this statement? Anybody? Okay, so let's see what happens. So the trigger runs, so the block that includes before a statement runs once. Then the block that includes before row runs, oh, that's actually very interesting. Runs 3 times. It runs 3 times because we have 3 rows inserted. And after row runs 3 times, that 3 rows are inserted. And also, we have trigger 3 running still, because trigger 3 belong to invoices, to the invoices table. So trigger 3 also runs, and it was after each insertion, after each row, after each update, because trigger 3 is the audit trail, remember? So the audit trail also is running, is still running. And then we have the next row, and the audit trail runs for every row. And we have the blocks before row and after row running for every row. And at the end, we have the block for after a statement running once. The block for adding statement runs once, and then it says 3 rows updated. That is the message by Oracle. Beautiful, isn't it? So we ran how many blocks? 3 times 3, 9 plus 2, 11 blocks. 11 blocks of code were executed through triggers. So, any question? Okay. So, now that we have time, I'm going to talk about mutating tables. It is not that important. You may not need it. You probably will not encounter that situation. But how do we solve the problem using compound triggers? We had this problem here. We wanted to make the changes into items, and according to the changes, update the invoice total in the invoices table. So, we face the problem, mutating table. How can we solve it using compound tables? Compound triggers. Can you guess? It is very straightforward answer, actually. The trigger caused the problem if it was for each row. If it was not for each row, it wouldn't cause a problem. But if it was not for each row, the select statement and the update statement would be meaningless. Yeah, we didn't know where to update. So what we can do here is this. We simply, let's go to the trigger that we were trying to use. So this is 2B, this is the trigger that actually caused the mutating problem. So what we can do is that we can just make the compound trigger that does this. Before a statement, it does the select. So before a statement can use the select, there is no problem because it is not for each row. If we remove the for each row part, it works. Yeah. So we do before each statement, we select this, we extract the information, and then we go for each row. After each row, so we have after each row, for each row, we put the new information there. So only the trick is that you have to use the declare, as we have in the compound trigger. You have to use declare to pass information between the blocks. So you have to use actually the new variables. So you have to define variables here to pass information between the blocks. So you get the information, and then you pass the information to the new block and do this. So essentially what it does is that for each insertion, for each change in the items, it does the summation, use the select statement, does the summation, and goes there and updates the invoices and passes the information. But
How do you pass information?
passing the information. So the variables that we define here before the blocks, after compound trigger. These variables are shared among all of the blocks. So the blocks share those variables and can put values there and take values.
So you can't specify you only have one constant?
You can what?
You can only have one constant. Or what if you need a whole multiple?
Multiple. So let's say, for what do you want me to do? What change do you want? I can't do it. So
Lines to update, and then you need values for them later on.
yeah. So here, for example, in here I can have select, yeah, and whatever I want, and into some variable here, some variable number, and then select something from the invoices, invoice total, let's say, because we are in the invoices table, and that was the problem. So I can easily do that. So I can, in the before statement, I can select from the table. No, I can select from the table that I'm calling, that the trigger is on. The problem is that I cannot do the select before each row or after each row. You know, that will cause the mutating problem. So I can say select blah into the some variable, and from the invoices, whatever. Okay? And what happens is that I have this variable, I have the proper value into this variable, and I can use the value here or after each row, and then use to insert into the other table. So we have time. I wanted to show you something very interesting. Now that we know triggers, I want to show you the value of triggers, how we can use the value of the triggers. The value of using triggers. So, I don't think we need this anymore. Okay. So, remember we had a one-to-one relationship. Imagine we have one-to-one relationship between two entities, between two tables. So let's say students, and what is a one-to-one relationship? Students and dorm rooms. And the one-to-one relationship, this is totally fine so far. Have you noticed that we try to avoid mandatory to mandatory relationships? Even one-to-one or one-to-many. We always try to avoid mandatory to mandatory relationships. Imagine it is mandatory to mandatory. What happens? Each room must have a student, and each student must be assigned to a room. Each student must have a room, and a room must be assigned to a student, and only one student. It is one-to-one, and it is mandatory to mandatory. What is the problem with this? With this database, this relationship. Imagine I want to add a new student. Can I add a new student? No. Why not? I need a room. So, imagine if I want to add a room. I need a student. So, essentially, it is this database cannot be used. Yeah? This database cannot be used. And not only it cannot be used, it doesn't make sense, essentially. And in the rules, you can have a student as required, and in the student, you can have room as required, and you can enforce it, of course, you can enforce it. However, then the database will be useless because you cannot introduce any information. So, how can we solve it? We combine the two tables. That's another reason that we prefer to combine the two tables on one mandatory to one mandatory relationship. The two sides of one mandatory to one mandatory relationship. That is one reason that we better combine them. Another reason is the speed and efficiency. Okay, so far so good. Now imagine that we have one-to-many relationship. And it is mandatory. So let's say we have majors, and the student must have a major, and the major must have a student, at least one student. So can I add a student? Can I add a student here? Can I add a student? I should have a major for it. I can add a student for an existing major. Okay? Can I add a major? I can only add major for existing students. So the problem here is that I cannot add a new major, actually. If I want to add a new major, I need to have students already there with that major, so it doesn't work. Yeah? So this database is useless, and there is also one more problem. The enforcement. How can I enforce this? So where should I put the foreign key? Where should I put the foreign key? Come on. It's in the first week. Students. So it is always on the many side. So here I put the major for each student as foreign key. Okay? And how can I enforce the one-to-many relationship? I just did the foreign key. The foreign key enforces the one-to-many relationship. So we have one-to-many relationship. How about mandatory? So a student must have a major. It is mandatory. So it is required. I can make it not null. Not null. Okay, so it became mandatory. So I have enforced this too. I have enforced this. This. How can I enforce this? A major must have a student. How can I enforce this? You cannot have a major without a student. The mandatory side on the students. How can we enforce it?
In the database?
What?
In the database?
Yeah. So we enforce the other side using not null here. How can I enforce this mandatory side?
Constraint.
Constraint?
Yeah.
So where should we put the constraint? In which table? What was the topic of today? Triggers. So, we put a trigger. The constraint is this. The constraint is simply this. We cannot have a major without a student. Each major must have a student. Yeah? So the trigger should be on the majors. So we make a trigger here, and we put before, and the trigger prevents inserting any major that doesn't have a student, essentially. And it would be great if we had this optional. So imagine if it was one optional. So we could have a student without a major. Just imagine if it was like that. We could put a trigger here and say that you cannot do this, and then they put a student there, and the major should assign to a specific student. We could have a majorless student, and we use that majorless student to insert a new major for that student, and everything would be fine. Okay. However, we have this. Still, the trigger would be fine. Still, the trigger works fine. We should have the trigger to prevent adding a major. Actually, we should prevent adding a major anyway. Yeah? Because it is impossible to add a major this way. Because if you want to add a major, you are violating this rule anyway. So far so good. Now we succeeded to enforce the rules. We succeeded to enforce the rules. So we are at point at square one, where we have one-to-one relationship. Remember? So in one-to-one relationship, you can enforce the rules. The problem is that the database will be useless. You can enforce it easily. Just not null here, not null here. Not null, not null. Okay? It enforces mandatory to mandatory relationship. Here, we can enforce this mandatory relationship using a trigger. And we can enforce the mandatory to mandatory relationship using a trigger and a not null. Okay? So in both cases, the database will become useless. We can enforce them, but the database becomes useless. Here we can solve the problem in one way. Combine the two tables. How can we solve the problem here? How can we use the database here? How can we enable adding here? Adding new data here. What? No, you cannot. Actually, you can combine. You can put the majors in the students, but you're violating the normality. So it will be a partial dependency, and it will be in the first normal form. It will not be in the third normal form anymore. You can do that, and sometimes it is good to do that. So imagine we don't want to combine. For some reason, we don't want to combine. Here, we don't want to violate normal forms. And here, we just don't want to combine. Okay? How can we solve this problem without combining? Functions and procedures. So you can define a function or procedure, actually a procedure in this case, just procedure would be fine, you don't need function. Procedure, that the procedure takes the information from both tables and adds the information into both tables at the same time. Okay? The same here. You can have a procedure that adds the information to both tables at the same time. What do I mean at the same time? You have insert, insert, commit. Exception, rollback. So it inserts in both tables or none of them. Okay? So you define a procedure that inserts the rows into both tables or none of them. And that's how you enforce the mandatory part. That is how you should enforce the mandatory part. And then you remove this from the tables. So you don't need to enforce the mandatory part in the tables anymore. You use the function, you use the procedure to insert. So you control adding information to the tables using the procedure. Okay? Any question? Okay, so we finished. Now we are actually potential database administrators. We learned a lot, yeah? It was a lot, and I promise you, someday you will thank me. It is gonna be very helpful to you. And when you work, when you get a job, then you realize how important databases are. And for the exam, it is gonna have the same style as before, as exam 2, so it is gonna be cumulative. So the exam will be from the whole semester of everything that we learned. And also it is gonna be multiple choice, and probably I'm gonna include 2 extra questions as bonus points. Do you like that? So the exam can be 260 points. That means if you answer all the questions in the exam, you will get 20 extra points. And it's gonna help you if you did not do well in the first or second exams. So I think it's gonna help a lot. And that's it. So any question? Any other question? So thank you.